Hello everyone, welcome back. In the previous video, we have designed the individual parts of our conveyor roller project. Now, in this video, we will assemble all those components together and create a new proper working conveyor roller assembly using bearings and locking arrangement. So, in this video, we are going to learn how to select bearing and its fitment and how to lock it. So first let's open our shaft and go to the file, make assembly from part. Just click on OK. You will get the shaft at the center. Now we will add the tube, which is also known as the roller sleeve. So open it and place it. Now we will add some constraints and mates. So give concentric. Now this sleeve is moving, so we have to place another mate. So what we have to assure that our sleeve should be at the center of the shaft, so we will select the both faces of the sleeve and both faces of the shaft. Use the control key to select, and here we can see the width mate is appear. So click on it and click on OK. Now we can see our sleeve and the shaft is constrained now. I think we should use some color for that. So that uh, we can easily identify the sleeve and the shaft. Okay. Now I have already downloaded the SKF bearing here 6002Z. Now, okay, we will add concentric and the coincident met. Okay, for the other side also copy the bearing using the control key. Just drag it and you can see we have a copy on it. Just take a concentric and coincident. Okay, now we will take a section view so that it will be a more easier to understand. We can see over here, this is our bearing and the inner race of the bearing is resting on the shaft. Outer race of the bearing is resting on the sleeve side. Okay, I will just let you know I have changed the dimensions of the inner diameter of the roller tube and the step which we have created. as per the dimensions of this bearing inner race, outer diameter of the bearing race, and outer diameter of this outer race. Okay, so yeah, we can change the dimensions from just by double clicking on it. We can change the dimensions from that. Okay, so keep in mind that we can change the dimensions from directly from the assembly level. So that's why I told you in the previous video, we can have the dimensions. If we don't know the dimensions, then we can have the dimensions whatever you like. And after assembling, while assembling, you will come to know that this dimension is not appropriate, so we have to change it. So we can change it. Now, just I will tell you how I selected the bearing. So this is the SKF website. Here we can go to the home page, products, rolling bearings, ball bearings, deep groove bearings, and here we can have the selection uh, from the filter. We can have the bearing. I think okay, yeah, this is a filter. So I have just placed the 10 bore diameter, which is required, and we have all the bearings which has okay. We have only 5 bearings which has the bore diameter is 10 because we have selected the 1 to 10. That's why it's showing the 7, 8, 6, 5, 9, and 10. So we have to select the 10. So I have selected the 60002ZC3. Here we can have the outer diameter at 26 and width is 8, and the basic dynamic load rating is 4.75 kilonewtons. So it's a good load rating. In the upcoming videos, we will have the calculation part. So how we can select uh, uh, the diameters and the thickness of the rollers uh, in terms of the load, the radial load on it, and the UDL on it. So we will have that videos in the upcoming sessions. So the limiting speed, we have the 34,000 revolution per minute. So the RPM of the bearing is limited for the 34,000. So that we have selected this bearing and we can download this CAD model from this. So we have a CAD. We can select the format for that. I have selected the step AP203 and just download it. And now we have to lock this bearing. So for that, I will add the circlip. So take a circlip as a normal. Heavy circlip is not needed. So outer diameter of the bearing was 26, so I will keep the 26. Now, okay, let's take a 2. Click on escape. Now we have to make some groove here to place this circlip in it. So for that, we have to know the thickness of the circlip is at 1.2 mm. So we should have at least 1.3 or 1.4 mm of groove over on it. So we can directly add this sketch into the previous sketch. As you can see, I will add one rectangular line. We can have both. Yeah. So now friends, we know the 8 mm of width of our bearing is from this. Now we have to take the groove dimension as let's say 1.5. We'll take a 0.3 mm plus of the circlip size, and from this end uh, we will keep, let's say 2 mm. So 1.5 and 2 is a 3.5. Total is 12. Now what is remaining? Remaining is 8.5. So 0.5 mm only. So it's not enough. So we will keep 1.5 mm from the outside of the face of this roller tube. And how deep the groove should be. Actually, this size, circle size, and its seat, we can have this. Okay, I actually, okay, it's a 1.5, not a 15. Okay, now to select the this size, we have to consider the design uh, data book. In that, we have the dimension and how the groove size, the outer diameter of the groove size, what should be, and the inner, the thickness. So we will just keep this as, let's say, 2 mm. Okay, now we have to trim this side, this line, because this is a revolve feature, so all the edges should be closed. No overlapping is allowed in this. So take a trim and just drag to this, so we can see this is now in the shade form. Okay, now we can have the mirror. So let's take a center line, so that we can have the mirror feature. Just select whatever you have to mirror. So I have to mirror these three lines. Okay, go to the mirror entities and mirror about this center line. So okay, there is one dimension. Okay, I will click on OK. Here the our constraint is, I think, deleted. Yeah, because we have trimmed this. So I will just add one constraint. Okay, it's a 12 mm. So I will add the dimension. It's 12 mm. Okay, now we have to trim. So go to the trim and just drag it. Now click on OK, exit the sketch. Now we can see there is one groove here. To add our circlip, save this and go to the assembly. Yeah, here we have to provide some mets. So we will add the coincident met first. Yeah, and then concentric met. System is in a hanging mode. Okay, so our circlip is now at the perfect side. So other side also we will keep the coincident at this face. And the concentric mate we can have the concentric mirror on any faces of this roller tube. Okay, now it's fit and fine. Now we will take the section view so that we get the clear idea. Okay, so I don't want this blue line. Yeah, now you can see our outer diameter is wrong. That's why here the gap. That's why I told you that this size is actually as ISO standard from the design data book. Uh, but I don't want to get too much deeply into that. That's why I just kept this random. But you can have a check on it and just let me know what is the outer diameter should be for this 26 mm inner circlip, so that we will have the better idea and you will also come to know. So yes, that's it. We have made our first roller, and congratulations for that. And yeah, thank you for your concentration and the patience. So we will see in the next videos, uh, like exploded wave and the other things like yeah, I already know the run interference detection, I think. So in the next video we will uh yeah, okay, I think we should make one stand structure so that the major part of the conveyor is a stand structure and the roller. So we have made the roller, so we will try to make a stand structure, and mm, we will see how to fix this roller to the stand structure and how our conveyor is uh, going to be a perfect as per the industry requirements. So thank you so much. We will see you in the next video.